All right, great. Well, we're at the top of the hour, so we'll just go ahead and get started because these are mini podcasts. And the voice that you hear speaking is Paige Donner. I'm the host of this mini podcast, and our featured guest today is Zach Hynek. Just to set the stage a little bit, you are attending the expert conversations on the future of energy, AI, and fusion. And these are a series of mini podcasts imagined for U.S. fusion energy and also beyond, much in response to what's going on with the Genesis mission and, AI being rolled out at our Department of Energy labs, AI's co-scientists. So a lot of really interesting things to delve into. More than we'll be able to get into in 15-minute podcasts, but at least we can kind of scratch the surface, if you will. So I'm going to go ahead and stop the screen sharing since everybody now knows where we are. But I do want to say a big thank you to U.S. Fusion Energy and its founders, Steffi Deem, Oak Nelson, and Arturo Dominguez. Without whom, I mean, this is a labor of love for them. So without whom we would not have this platform. And, as fusion energy accelerates, I think it's really essential. It's extraordinarily important that we have this opportunity to be able to talk about it in layman's terms, in expert terms, in all terms, right? So I have Zach Hynek. He's our featured expert speaker today. And this is just conversation style. We'll leave a few minutes at the end. Really, this is only 15 minutes. So a quick intro. I'll let Zach introduce himself more fully. He's the co-founder of MortonLabs, a spin-out from Chicago, University of Chicago, and he's doing all kinds of really interesting things in fusion energy. Just to give a little bit of context as to who I am, I'm the owner of IoT Logistics LLC, which is a woman-owned small business. I've been communicating about fusion energy since 2021. I was awarded a Filecoin Foundation grant in 2022 to do a series of expert interviews on fusion energy, CEOs, founders in both Europe and the United States. So that kind of situated me. And it was good timing because it was several months leading up to and after the NIF, the National Ignition Facility breakthrough in December 2022. So, wow, talk about momentum. But that's enough for me. And this is my second year hosting podcasts and expert roundtables for U.S. Fusion Energy. Thank you so much, U.S. Fusion Energy, for this opportunity. But Zach, you're doing such wonderful and groundbreaking work in fusion energy. And you and I actually connected specifically over the open source software for Fusion Energy Conference, which I would really like to focus on mostly during our conversation, as you and I discussed previously. But please give us a more in-depth introduction to yourself. You are CEO of MortonLabs, a new venture, as we just noted, spun out of University of Chicago, and it's a platform built specifically for the design, planning, and simulation efforts for nuclear power plant development. Please take us further into what you're doing because we need to hear it from the source.
Yeah, well, Paige, I appreciate it. It's always intimidating whenever you're referred to as an expert in the nuclear fusion space. So to immediately discredit myself, I'd say I got started around the same time in the nuclear fusion space, really just helping out a pair of researchers and scientists who, one was at the University of California, Berkeley, earning his PhD in nuclear energy or nuclear engineering, and the other was building particle accelerators out of another company in Utah. And between the two of them, they had a novel concept to build their own fusion energy reactor. now fusion energy system and machine, as we should call it. And I think one of the things that really just stood out to me at that time was not even just the advances and all the momentum that we started to see around that same 2022 NIF results, but also with the rise of AI and data centers and everyone talking about how are we going to get more power on the grid. I thought that was very coinciding timings, but what was really just most inspiring to me were these researchers who were dedicating their entire life to science and these projects that people have been going after for decades and decades, almost 100 plus years, to be able to unlock this power of the sun here, right here on Earth. So what we wanted to do, or what I was originally just helping them do, and even when I came to the University of Chicago, it was to better understand, how do you finance these deep tech R&D projects? How do you commercialize fusion energy in the state that it was, and still the technical readiness level that it was at the point in time? And I went to the University of Chicago at the Chicago Booth School of Business, but also at the University of Chicago, home to the first ever sustained nuclear reaction back in 1942. And what was really inspiring to me is my background was a lot more on always the business development and even the fundraising side, was that some of the first involvement within nuclear energy and within our nuclear energy program, even before the Manhattan Project, was from the actual Rockefeller Foundation. And it was through philanthropic endeavors that were actually funding Lawrence's cyclotron that he had at Berkeley in 1939. And a lot of those scientific advances led to what we know about our whole nuclear energy program here. But those efforts within the Manhattan Project are also what led to our national laboratory system. And over that same time, as I was helping support these researchers out of the University of California, Berkeley, we also realized that one of the things that came up was to be able to get to the proven verified results that we needed to get through abundance of simulation data. And we needed to actually prove that our models were accurate and that our approach was going to work. And we partnered with the University of Chicago, some of the folks over in our computer science department, to get better access to the simulation data. And that's when we immediately started to realize that, wow, there are still a lot of challenges and difficulties when it comes to obtaining the results that you need to be able to not just prove your experimental designs, but to have to navigate, I'd say, all the different fragmented ecosystems that live within not just our national laboratory system, but within that kind of software system itself. And the open source software community has actually been a really positive answer to a lot of those same frictions and bottlenecks, where you have some of these same most dedicated advanced researchers in the sector and space who are actually coming up with the codes and the algorithms to be able to prove that their designs and approaches are going to work. And they're actually, what they're doing is they're giving away that same resources for free. And I think it's something that has inspired me, of not just the open source software community, but still just not gatekeeping science, as we still are seeing all of these billions of dollars poured into the fusion ecosystem right now. We're still seeing these scientists who are working in the laboratory and are on the ground floor doing the work. And that's a little bit of what's happening behind the scenes, of how both simulation software is helping kind of improve the design and the theory that we're using to be able to optimize our reactor and our design choices. But it's more important is that we're actually not kind of gatekeeping or having to go through the same challenges or hurdles of being able to model those results, which often is a lot of complex just programming work, which is a lot of the same work that our company here at MortonLabs is focused on.
Yeah, I mean, this is such an interesting facet of the interplay of what's going on. I mean, when I mean, I did read through the DOE Genesis mission RFA, and they talk a lot about ModCon and AMSC in there, and I realize you submitted to that too, so bravo. But I think, when you're talking about open source software, and then you're and then you look at what they're looking to engineer, like this collaborative space, how would you juxtapose those things? Are they at odds, or are they kind of in sync? I mean, I know open source software is it's definitely its own thing, but this is kind of an interesting direction that they're taking things in, isn't it? Because I mean, ModCon, isn't the idea behind that like a fully collaborative like platform?
think within the Genesis mission, what's exciting about this time is even when we talk about the rise of AI in data centers, and when we look at what an opportunity this is to be able to capitalize off of those scientific advances that are available to us and to be able to take this power of the computational resources that we have, so much of what we're still not able to do with AI is because we have limited data on one side. Just limited experimental data is one of the greatest challenges in fusion energy. But on the flip side of it, it's also so much of that data is kind of kept within the national laboratory system. And that's because so many of these codes or these systems were written for one-off experiments and they were not written to be reproduced. And sometimes they're written in legacy Fortran code that was, wrote in the 1980s or 1990s, even earlier than that in some cases. And it wasn't always maintained, and there's not great documentation for it. So within the Genesis mission, a large part of what they're trying to do is give the funding capabilities and the resources and the mechanisms for us to get that data out of our national laboratories and make it more accessible. But one of the challenges that I know we were looking at within our Genesis application and with support with some key players such as University of San Diego. We were working with General Atomics. We're working with a few other great partners such as NVIDIA and other supporters through that project. But how do you also start using artificial intelligence in these export control, nuclear grade secure environments is another extreme challenge that again stems from the Manhattan Project and even following the Manhattan Project to the Cold War, where we had this just era of secrecy, right, going on at the point in time where it wasn't until 1958 and we had the Atoms for Peace conference, or I think that was the Geneva conference at the point in time, when we really started declassifying a lot of these nuclear fusion research efforts. And it took us through even sometimes in the late 1960s to be able to show advances in certain confinement methods to show that fusion really was viable and possible today. But there's still a lot of work that needs to be done of getting that data kind of out of our lab systems, running more effective experiments, and making those experiments and even the analysis of those data and those reports more accessible to the everyday scientists and even to some of our grad students and postdocs who are looking to contribute more. But right now it still requires an immense amount of knowledge and research and experience to be able to know how to be able to more effectively kind of take what is simulation data and effectively turn that into more effective designs. It's the same way, how do I trust that this AI ChatGPT report isn't hallucinating? You need to know how to verify the science, and that's part of the effort of what they're doing within the Genesis mission, which is incredibly exciting time. And it's great to see that the Department of Energy, as well as the U.S. government, as well as our national laboratory system, has been so supportive to the private industry in helping kind of get access to that same research and that data.
Yeah, it feels like it's a different mindset. It's like really embracing acceleration, and what do we need to facilitate that acceleration? And yeah, and when you and I spoke a few weeks ago, yeah, the guardrails around that simulated data is going to be very important. And of course, that's what we do at Frontier Registry, not to give myself a plug, but like that's what we've been focused on for the last several years. How do you, if you are going to be using a lot of simulated data, how do you how do you verify, how do you protect the integrity of it, right? But one thing, actually, there were a couple of points that you made in several of your LinkedIn posts that I thought, they had a lot of weight to it. You talked about the source code, the source code that you just referenced that they were using in the 1970s, and that there was C++, but also the point that when you use open source software, it's open, but it's not necessarily free. Right. I thought that was a really interesting point too. So how is the commercialization of fusion energy going to be able to sync with open source software?
Well, I think one, you can't take away the reason open source software has gained so much traction within this advanced energy and the nuclear fusion space is because, first and foremost, it can be trusted. Because they're giving it away open to the public, you can verify those results more easily and more accessibly. And that's a huge part of it. These results can be trusted. And these are some of our greatest researchers and scientists amongst the world right now who are verifying that data. But even they themselves are limited with their capacity, their time, their resources that they have. And now what's been an interesting kind of dichotomy is with the advance of AI and these coding agents, we're seeing that they are being kind of swarmed with even more pull requests and even more submissions to contribute to those codes, which are great in the open source community. But we still have this bottleneck of it needs to go to the actual end developer who it knows the source code well enough to be able to understand what can be meaningful contributions and what can still be trusted without breaking the integrity of the system itself. So that alone is one of the bottlenecks that does exist. But as we know, with any type of software, development, the cost of being able to maintain that same software is its own price tag. So to be able to have the specialists who know how to be able to use these tools in the first place, to be able to know how to maintain these systems and continue to integrate them into your stack, also in a world where software is changing by the second, it feels like at this point in time. So those are the things that we really help kind of take that burden off the plate of some of these companies here at MortonLabs by making our team that is really built off that software experience and systems engineering. And I think that's also why I'd advocate for just more kind of third-party developers and consultants and kind of contributors such as those open source developers themselves. Those are the people you really want to reach out to and the people you want to connect with because they are the leaders in the sector and space. And I'd say the ones who know kind of what good looks like and what right looks like versus wrong.
No, yeah, nice point. Nice point. Well, shall we open it up for the last couple of minutes? We've got about 3 minutes here. To anybody in the audience who would like to ask a question or make a comment, you can raise your hand. It's probably the best. Or if you're the quickest one to unmute, you can go ahead and do that too. I saw Lars is unmuted. Lars, did you have something that you wanted to say? Oh, well, actually, I think Christopher Billingham just beat you to it. So, Christopher, I just gave you an invitation to unmute.
Right. I'd like just a question. What you spoke about the open source software, of course, is a celebrated institution, particularly in Fusion. With the recent advent of AI, particularly tools like Claude, Gemini, you obviously mentioned the need for still dedicated experts to vet and maintain open source libraries. But if you'll excuse the expression, how do you think that the rise of AI, scientific machine learning, is affecting the economics of open source software? I mean, there is with agentic AI. How do you feel that there is less of an incentive to use a dedicated library versus making one's own solution?
No, it's a great question. I think we've seen this in the community as well as industry leaders are choosing to be able to develop their own software simulation stacks in-house right now. I think the fact that they're able to move so much more efficiently and effectively is one of the powers of artificial intelligence. I also think, Chris, to your point, one of the greatest challenges that still exists is how do you actually interpret those results and how do you go through the analysis portion? And I think that's something that we're working with these AI systems, but I was really surprised by, a comment from the team at Lawrence Livermore who just ran one of their big NIF polls. They fired new shots and they had been pulling through the analysis for months at the point in time, is what they said. Not days, weeks, but months of still just interpreting the results, which to me, I think just goes to show. And I had asked their team the question of how are they using AI and artificial intelligence to speed up the process. And I think I'm very cognizant and trusting of some of those leaders in the space when they say that today they're just still experimenting with how they can use that data, but they're doing it on a very limited fashion. And I think there's a lot of great researchers out there who will tell you that you can't speed up that time of the verification part of the process because it really does take that level of expertise and knowledge and wherewithal. So I think those are the things that we're we're acknowledging, but when you talk about the economics of, that kind of build versus buy decision, I think it is, you could see very clearly of the companies who are giving away their data or giving away their tool stack, but still being incredibly competitive on a unit economic level is kind of, whether it's through the DeepSeek models that they have or the open source software. I think one kind of affects the business strategy and the models of the existing players in the space, who are the OpenAIs and the Anthropics of the world, who have such a for-profit model. But I also think it kind of challenges this idea of, is IP really your moat that you have? And maybe it could be more encouraging for these private fusion companies to be able to share more or open source more of their own software and their own tooling, because it's not maybe it's going to be execution that is going to be the real difference maker for them, not necessarily the use of certain software, AI, or one code or the other.
So interesting. I think this is going to be a very big conversation going forward. Yeah. Lars, you're still unmuted. Did you have a question, or did you just...
No, I'm just having problems.
Okay, all right. Then I think Roshan had a question, and then that'll be our last one, and then we'll have to jump because we're already over.
Yeah, hi. Thank you very much. So I do a little bit of simulation for a private firm in the fusion industry. And I was wondering how MortonLabs could help me with, I don't know, validating my simulations and what kind of services you provide in that sector. Because I was wondering how I can kind of like benchmark my simulation results against others, validate it, etc. I don't want to be operating in a bubble and not knowing, if I'm right or wrong and things like that.
Yeah, I think there's one certain frameworks, and Roshan, we could discuss offline, connect offline as well. I think in general, what we're seeing amongst the entire fusion community today is how can I take this experimental data and validate it against what is the limited benchmark data today? So understanding what some of those data sources are, there are certain of those libraries that exist. I think the IAEA has one that's available. General Atomics is releasing just recently the FETR database. So you could start to get access to some of these libraries where you could find that benchmarking data, which, man, has been a challenge. It's like you're navigating a lot of different searches and volumes of textbooks to even see what is out there in the first place. To Chris's earlier point, that's one thing that we've seen LLMs and AI be able to help even just find and locate some of those studies in the first realm of it. The second piece is actually engaging with one of these, whether it's a university partner, national laboratory, or someone who has some sort of experimental data that you can get access to today. And then I think it's the process of, how do you build that verification, flywheel into your simulation process. There's a few different kind of workflows and strategies that we could talk about to be able to do that. But happy to kind of connect offline on a more technical level.
Yeah, thank you.
Cool, great question. Zach, do you want to drop your LinkedIn in the chat just before we jump off? Or you're pretty easy to find on LinkedIn.
Yeah, you could find me on LinkedIn. You could just search for MortonLabs.ai, and we're definitely pretty active on social media as well. So really great to connect. Thank you again for the time today, and hopefully we have a great rest of the week for Fusion Energy.
Yeah, thank you so much. Thank you, Zach, for doing this. And thank you, everybody, for jumping into this mini podcast. So we have another one on Thursday and then another one on Friday, different times, but it's on that page that was shared at the beginning. So thank you, everybody. And thank you, especially Zach, for your time and sharing all your expertise today. And thank you, US Fusion Energy. Thank you so much. All right.